So remember in an earlier video, we talked briefly about how proteins have not only evolved to have certain functions, so in this case, binding of oxygen, but they've also evolved a lot to avoid unwanted functions, such as binding of molecules that we don't need. So the question then is, if myoglobin can bind to O2, why can't it bind to other molecules that have oxygens in them? So let's take, for example, maybe something like acetic acid, or acetate rather. So that's more likely to be found in a biological system. So this is, so acetate. So why can't acetate bind? That wouldn't be acetate. That's acetic acid. All right, so why can't acetate bind? So if you look at some of the other surrounding residues, so there's a pocket. So recall that, again, earlier we discussed that something that has a molecular shape that matches the molecular shape of the active site can bind in to the ligand binding site, but a different molecule that does not match this molecular shape can't, right? This is inhibited, again, by the molecular shape of the ligand binding site. And so what actually makes this, this molecular shape is the amino acids that create this pocket. So this pocket that surrounds this ligand binding site. So again, we have, for instance, the distal histidine up here, which acts in a very direct way to stabilize by hydrogen bonding any oxygen bound here. But what about these other residues? For instance, this phenylalanine, which is in the ligand binding pocket, or this valine over here. Okay, so these are just the side chains, and those come from the peptide itself. And so this limits the amount of space around the ligand binding site and creates this molecular shape. And so things that are larger than, for instance, oxygen, so O2 is just diatomic. That is to say, there are only 2 atoms, versus acetate, there are several more. This is too big to actually enter the binding pocket. So this excludes, sort of, you can think of size exclusion almost in this case, except a much tinier pore, right? And so this excludes acetate from entering into the ligand binding site and prevents it from binding to this iron. And so that keeps this available for O2 to bind, and other small molecules that have carboxyl groups such as acetate, or maybe an amino acid such as glutamate or aspartate can't creep into this ligand binding site and take up the spot which is supposed to be reserved for oxygen instead.